In this section, we're going to be looking at solving linear inequalities. And we'll start with some very basic ones and work our way up to more complex inequalities, including inequalities that have an absolute value in them. Before we start working problems, let's review some properties of inequalities. Okay, if A is greater than B, then A plus C will be greater than B plus C. Just like in an equation, if I add the same thing to both sides, I've preserved my inequality. Okay? If A is greater than B and C is greater than 0, that means C is positive, then AC is greater than BC. Again, just like an equation, I can multiply both sides by the same positive number and get this same inequality relationship. This last one is a little different. If A is greater than B and C is less than 0, so C is negative, then AC is less than BC. So in this case, when I multiply by something that's negative, I have to flip my inequality around to maintain a true statement. Okay, pause the video and let's work on checkpoint 1. Let's work a basic inequality problem. I'm going to start with 3x plus 5 is greater than 11. I'll work this inequality exactly like I would work to solve an equation. So I'm going to start by subtracting 5, which gives me 3x greater than 6. Then I divide by 3. And since I'm not dividing by a negative number, I do not have to adjust this inequality symbol. So I get x is greater than 2. Pause the video and work the problems in checkpoint 2. In our next example, the inequality will have a variable on both sides of the inequality. And again, we're going to solve this just as we would an equation. So we start with 4 minus 3x is less than 7 plus 2x. Okay, and I like to remember the first step by remembering the country music song, All My Exes Live in Texas. So I'm going to get all my x's together. So since this is negative, I'm going to add 3x to both sides. So now I have 4 is less than 7 plus 5x. And then I can subtract 7, which gives me negative 3 less than 5x. My next step is to divide by 5. And I have negative 3 over 5 is less than x. Okay, they asked me to graph this, and I only need a number line to graph it. I've provided you with number lines on your checkpoint sheet. There are no numbers on them. You put whatever numbers are necessary I don't necessarily need to see 10 numbers on the line. Just use the ones that you really need. So in this case, I need -3/5, so I'll put 0 in here and -1. And then -3/5 would be right about here. Okay? Reviewing our rules for graphing on a number line, because this is less than and not less than or equal to, I can use either an open circle or parentheses. So I'll show you both ways. And you may use whichever one of these you prefer. If I use an open circle, I will put that right here at -3/5. X is bigger than that. So we're going to shade to the right. To use parentheses, because again, I don't have the equal bar, I would use parentheses instead of a bracket. I just replace that open circle with the left side of parentheses and again, shade this direction. So either way is fine with me to show your answer. Pause the video and work on checkpoint number 3. Unlike an equation, an inequality often has 3 parts. The method for solution remains the same, except instead of doing something to both sides, we have to do something to all 3 parts of the inequality. Let's take a look. Got -2, which is less than 5 plus 3m less than 20. Okay, to work this one, I see that I only have m one place, so I don't have to get variables together. And so I'll start by getting rid of that 5. So -5, -5, -5, 3 different places. So this is now -7. I've got 3m here because these canceled out. And then 20 minus 5 is 15. Next, I'm going to divide by 3. Which gives me -7/3 m and 5. Okay, 7/3 is -2 2/3, 2 1/3, if you prefer to think of it that way. So here's my number line. I'll put a 0 there. And I'm going to put 5 out here. And then, again, -2 1/3, so 1, 2, and a little bit past that. -7/3. And again, you can use either open circles or parentheses. I'll use parentheses on this one. So I'll open the parentheses here, close them here, and shade in between. Okay, m is in between -7/3 and +5. Okay, it's time to work on checkpoint 4. Because we live in one of the only countries that doesn't use the Celsius scale for temperature, we often have to change Fahrenheit temperatures to Celsius temperatures. So we'll look at a formula to do that and use it in an inequality. So in this one, we say the formula to convert from Celsius to Fahrenheit looks like this. F equals 9/5 C plus 32. And we're asked to find a Celsius temperature range that corresponds to a range from 32 to 77 degrees Fahrenheit. So we're going to put this formula 9/5 C plus 32 in the middle of an inequality, and on the outside we're going to have 32 on the low end, 77 on the high end. And now we work this just as we would any other inequality. So negative 32 first. And I get 0 less than 9/5 C less than 45. Okay, to get rid of the 9/5, I'm going to multiply by its reciprocal, which is 5/9. So now I have 0 times 5/9. This is going to cancel out, and I'll have just the C. And then over here, I'm going to have 45 times 5/9. Well, very conveniently, 45 is divisible by 9. So I can cancel that out and change this 45 to just a 5. So I end up with 0 times 5/9 is just 0, less than C, and less than 25. Okay, so our range for Celsius temperatures that matches the 32 and the 77 is from 0 Celsius to 25 Celsius. Go ahead and pause the video and work your next checkpoint problem. In our next problem, we'll look at a practical application for business. It says a company analyst has determined that the cost to produce and sell X units of a certain product is C equals 20X plus 1,000. Okay, the revenue for the product is 70X. And we want to find the values for X for which the company will either break even or make a profit. So we want the profit to be greater than or equal to 0. If the profit equals 0, we broke even. If it's bigger than that, then we've actually made a profit. Okay? From what we've done before, we know that profit is equal to revenue minus cost. So we could say profit is equal to 70X minus 20X plus 1,000. And when I simplify that, I get 50X minus 1,000. So this is the expression I'm going to use for profit. So I'm going to have 50X minus 1,000. I want that to be greater than or equal to 0. I'm going to start by adding 1,000 to both sides. So now I have 1,000 over here and 50X here. When I divide by 50, this goes away, all I have is X, and this is 20. So my answer is that x has to be greater than or equal to 20. I have to make at least 20 units to make a profit. There's another way you can work this problem if you prefer, and that's just to make sure that revenue is greater than cost. So that would come out like this. 70x greater than or equal to 20x plus 1,000. And I think as you work through this inequality, you'll see many similarities to this one. And you should get the same answer. Here's another practical application problem. It says a pretzel manufacturer can sell a 6-ounce bag of pretzels to a wholesaler for 35 cents a bag. The variable cost of producing each bag is 25 cents per bag, and the fixed cost for the manufacturing operation is $110,000. How many bags of pretzels need to be sold in order to break even or earn a profit? Okay, in this problem, we introduce the concept of fixed costs and variable costs, which is very common in manufacturing. When I'm making a product, there are some things I have to have. I have to have a facility. I have to usually have power to my facility, and I have to have some kind of machinery. Okay, those are called fixed costs. And then my variable costs would include things like maybe employee salaries and the cost of ingredients, in this case, to make the pretzels. Okay, I have to put those two things together to get the total cost function. So let's set this up. Okay, my revenue to the wholesaler is 0.35 times x. I can sell these bags for 35 cents a piece. My cost is 0.25x, that's the variable cost, plus $110,000. And again, I want the revenue to be greater than the cost. So I'm going to say 0.35x has to be greater than or equal to 0.25x plus 110,000. Okay, I'm going to subtract the 0.25x. So that goes away. Over here I get 0.10x must be greater than or equal to 110,000. So then I have to divide by 0.10. And when I divide by a number less than 1, remember that I always get a larger number. So now I have 1.1 million. Okay, so I have to produce 1.1 million bags of pretzels just to break even. Anything greater than that, I'll get a profit. In the remaining examples of this lesson, we'll be working with inequalities that also have an absolute value in them. Just as a review, let me remind you that if I say the absolute value of x, that's equal to either x or negative x. That's what absolute value means. Okay. Let's look at some examples. When I have the absolute value of x is less than 5, sometimes it's helpful for me to think about this absolute value as a distance. So I could say the distance is less than 5. Well, distance from what? There's nothing else here, so I'm going to say the distance from 0. Sometimes it's helpful to draw a number line. And here's 0. And if I go 5 units to the right of 0, I'm at positive 5. 5 units to the left, I'm at negative 5. And that distance has to be less than, so I have to be in between those two values right in here. On the other hand, if I say that the absolute value of x is greater than 5, that means that the distance has to be more than 5. So again, when I draw my number line, I'm still going to mark negative 5 and positive 5. But this time, the parentheses are going to face the other way. And I'm talking about this distance out here is more than 5 units from my 0, as is this distance. Okay, pause the video now and do some absolute value graphs on your own. Okay, go ahead and pause the video and work on checkpoint number 6. Before we go on to the next example, I have a couple of rules that I want to write down for you that might help you as we work through the more complicated absolute value problems. This is the first rule. If I have the absolute value of A is less than B, I'm going to solve this inequality that A is between negative B and positive B. Okay, that's like what we did with the first part of the last example. If I have the absolute value of A is greater than B, now I have to have two inequalities. Either A is less than negative B, or A is greater than positive B. Okay, so if you have trouble remembering what to do here, please write this down to refer to as you work through these problems. So now I have the absolute value of x minus 2 less than 5. And I want to stress to you, in this type of a problem, probably the most common error that I see is people say, well, I need to add 2 to both parts. Do not do that. Okay? Think of the absolute value symbol as a grouping symbol. Okay? I cannot take bits and pieces out of here and work with them as if they were not included in a group. So we are not going to do that. Okay? But I do have this absolute value is less than, so I can make it into a 3-part inequality. Negative 5 x minus 2 positive 5. Okay, I'm going to add 2 to all 3 parts. I have negative 3. These 2's cancel out. I have just x. And 5 plus 2 is 7. So on my number line, I'm going to mark negative 3 and positive 7. And my x is in between those two numbers. So I'll mark it here. pause the video now and work on checkpoint 7. In this example, we're going to look at an inequality where the absolute value expression is greater than the other side, and work that one. So let's start with the absolute value of 2 minus 7m minus 1 greater than 4. Now in this problem I have an absolute value expression, but there's also something else. So before I start rewriting this whole expression, I want to get rid of this piece so I have an absolute value all by itself on one side. This is not inside the grouping symbol, so I can go ahead and add 1 to both sides. And that gives me absolute value of 2 minus 7m greater than 5. Okay, now we're going to use the second property because I've got the greater than symbol. And so I'm going to have 2 minus 7m less than negative 5, or 2 minus 7m greater than positive 5. Please notice that this part inside the absolute value I did not change. I changed the part that was out here by itself, the negative 5 from the 5. Okay, that's another common mistake, is to try to change this absolute value portion. Let's continue on and solve each of these parts separately. I'm going to subtract 2, which is going to give me negative 7m less than negative 7, and then divide by negative 7. But when I divide by negative, then I have to flip this over. So I'm going to have m greater than 1. So this is one part of my solution. In this inequality, I'll work up instead of down. I'm still going to subtract 2. So here I'm going to have negative 7m greater than 3. And then I'm dividing by negative 7 again. So I have m, flip this over, m is less than negative 3/7. So here's my number line. The two numbers I need are negative 3/7 and 1. So we'll put 0 here. We'll call this negative 3/7 and this 1. And in this case, this is m is less than negative 3/7, so I have to shade this direction. And m is greater than 1, so I'll shade this direction. Okay, so you can see when I have this expression that represents the distance, if the distance is more than 5, I have to go out away from 0. If you're asked to put this in interval notation, this is going to have two parts. This part on the left is represented by parentheses, negative infinity, negative 3/7. Remember that when I use positive or negative infinity, I always use parentheses. And then the other part, so I say union from 1 to positive infinity. So this is the interval notation that represents the same thing as that graph. Pause the video and work now on checkpoint 8. In this last example, we're going to look at some things that can kind of trip you up and cause you to do a lot of work to get the wrong answer. So we're going to try to avoid that. If I have the absolute value of 3 minus 7x is greater than or equal to negative 8, before I start manipulating this or working on it, I have to think back to what the term absolute value actually means. Okay, absolute value is the distance from 0. And can a distance ever be less than 0? It can't. So if I have an absolute value that's supposed to be greater than or equal to negative 8, this is always going to be greater than or equal to negative 8 because this side will always be either 0 or a positive number. Now if I were to change the symbol around and say absolute value is less than or equal to negative 8, well, absolute value can never be less than negative 8. That would make it negative. So this inequality has no solution. Okay, so just a couple of things to keep in mind, especially when you see a negative number here. Now remember to always solve anything in addition to the absolute value, anything that's on the outside of that symbol, before you make that determination. Okay, this is the last example in this section, so you have one more checkpoint to work on, and then you'll be done.